to get vaccines and other countermeasures even before they infected humans. It sounds crazy now, but it's in retrospect. The President Trump issued an executive order saying no more dangerous gain of function. How have we forward?
Well, we are excited to work with you and the administration as the new policies are laid out, and we will absolutely follow the policies. And dangerous gain of function will not have any part in the portfolio of the research done at NIH or funded by the NIAID moving forward. As you said, it's important to know that we face novel infections usually from animals, that is zoonotic infections that have the ability to cause disease in humans, usually as small, one-off or small outbreaks, but sometimes a virus particularly, or it could be bacteria, can adapt from one host to another and can adapt to humans. We can't predict it. We can look at what's happened in the past. We can prepare for it in the way that you can design buildings to withstand
again, the host and the so having a healthy population, a metabolically healthy population, would be a great way to prepare for, uncertain new outbreaks.
Certainly, no, I would agree with that, and that's obviously critical. And having, a normal. Having your immune system develop in a normal way, which again comes back to the food allergies and relates to how the immune system interacts with the microbiome, is key. And so I think that this topic has been really important in our institute for a long time, but I think it needs to become an even bigger part of it and to live up to our name of the allergy part of our name.
Okay, so I want to first talk about some of the investments that the NIH has made in allergies, and in particular peanut allergies, because that's a topic, of course, that's concerned to so many people. I think I was looking at the numbers. It's like 1 in 10 adults have some food allergy, and 1 in 13 kids have some food allergy. And there's been a huge increase in these sort of atopic diseases in the last 20, 30, whatever time period you want. It's a real puzzle. I heard the secretary to ask about this, and he talked about it like a puzzle. Like what's the rise? Now NIAID has made some investments in this in the past. So like for instance, the idea that early exposure to peanuts can help prevent the development of peanut allergies later, that comes out of a trial that NIAID funded.
Correct. It's going back 20 years to 2005 when this was started and recognized as a really important clinical study. And I'm really happy to represent the institute that had that foresight and developed these clinical studies. And that LEAP study has led to a complete systems change in clinical care and practice, as we've been hearing all morning long. So very excited that AID was able to fund some of the key parts of that. So if you think about that and then the development of the omalizumab monoclonal antibody anti-IgE therapy, is two aspects of thinking about ways of treating and improving treatment for people who have such peanut allergies. What we need to do now and to go forward is to think about more research on prevention, and that is back to this key of how do we shape the developing immune system early in life so that it doesn't have this kind of allergic responses, but has more of a tolerant response. So the immune system has many different functions, but in T cells, one of their major functions is to recognize sort of self from non-self, right? And that's important in terms of infections, but our bodies, in terms of our GI tracts, our skin, our respiratory tracts, we're exposed to foreign substances all the time, right? And if we responded to everything as if it were a serious infection, we would develop all these inflammatory and immune responses that would be non-physiologic and would be dangerous. And so the key is, how can we look at what happens normally and what happens abnormally, and what are the triggers during development, and how that might relate to other physiologic, environmental, and microbiome changes.
I was sitting over there listening to the secretary talk about the lack of knowledge that we have about some of these topics. And I find myself agreeing with him about that pretty fundamentally. Like I think that it's important to know that early exposure might prevent the subsequent development, but yet, as the secretary pointed out, you still see many people developing allergies, food allergies in adulthood, right? You're seeing this sharp rise, and frankly, I don't know the answer to all that. And I mean, it sounds like that's.
I think that is the key aspect of what we need to do going forward. So another thing that that the Institute is funding that I'm very excited about is a big data project. This was talked about earlier in the day, but traditionally in science, you kind of do smaller science that's hypothesis-driven, where you actually test in experimental systems, the validity of your hypothesis or not. In this case, what I think is really important in this sort of big data idea, this kind of systems biology idea, where you can sample sort of everything, the host genome, the microbiome, looking at their immune responses, inflammatory responses, sample the skin, sample GI, sample serum, sample immune responses, sample cytokines, sample all sorts of things at the same time. You generate so much data that humans can't actually take it in and can't analyze it. But using machine learning and AI now, you can generate these huge big data sets and then mine them to help us understand the patterns of infants who develop various atopic responses versus those that are tolerant to those, and how are things changing, what are the biomarkers, and how can we use that to understand the basic pathophysiology of what's happening, to think of better ways to achieve prevention and then better treatments that are more tailored to individuals, for those who do still have these things.
So you have a full cycle. You've collected a lot of data driven with an idea of what you want to look at potentially, even broader than that. You allow people to ask questions about it, openly questions, even questions that are taboo.
Right.
You develop hypotheses from that, and the most promising ones you test with randomized studies, and I mean that sounds like science.
Exactly, and it is the National Institutes of Health, and while basic science is absolutely the absolute rock solid foundation of that, the goal is to take those understandings of basic science and translate that into improved patient care. So the goal, from the very most basic level up through clinical research, is always to advance and improve human healthcare.
I mean, to me, one of the reasons why I've been so focused on the replication crisis is that it really throws a wrench in this process, our learning, right? So you'll have products of science that come out, and you don't know if they're true or false, right? And it's only when multiple other independent authors look at the same thing and they find the same answer, you start to get more science is a process like that. And in a way, it feels like it got broken during the pandemic, pretty fundamentally. Like it was difficult to ask questions, like academic freedom. I could experience it firsthand. To me, like the exciting thing about being part of the NIH now is that we can be part of an infrastructure, an ecosystem that encourages people to ask questions, like that allows people to ask lots of questions. Okay, I promise you get back to the microbiome, and we have 2 minutes left, so let me get back to that. That's something I did not learn about in medical school. I'm ancient. It was like when the dinosaurs walked the earth, no one told me about microbiomes. And yet it's coming. It's the evidence that's emerging is that it's pretty fundamental to human health. Like the obesity crisis might be linked to problems with our microbiome. The food allergies we heard might have some. So tell us about the investments that NIH is making in microbiome research.
Yeah. So I can say that when you asked me to step up as acting director 6 months ago, the first meetings I had with the senior leadership of the Institute were to understand the research portfolio about microbiome. And after those discussions, I made this sort of snide but true comment that we have 150 years of literature on immunology and infectious diseases, none of which have considered microbiome. We should probably throw the whole literature. And that really is true. We are missing an enormous component of how functions and how the immune system develops. And the amazing things that we're learning about food allergy and the as it was said earlier, our microbiome is on all of our external surfaces, so that your respiratory tract, the skin, the genitourinary tract. So, I'm really interested in research on these other aspects that have been less funded, including, instead of just the colonic microbiome, what is happening in the much more metabolically active small intestine in terms of its microbiome. for example, and how the skin microbiome and immune responses to that affect the development of food allergies in the colon and vice versa, with this commonality of infants having both eczema and food allergies. And what is the crosstalk between the immune system, the inflammatory responses from that, and these different microbiomes? It's a whole new world, and this is absolutely a huge part of the future of the Institute if we're going to make any progress.
Yeah. I mean, it seems impossible to think about learning about eczema without thinking about the skin microbiome, for instance.
Right.
We're just missing a fundamental piece.
Right.
The Secretary mentioned alum exposure as a hypothesis for. What do you think of that, and how can we study that?
Well, I mean, as the Secretary said, I mean, this would require clinical trials, prospective clinical trials, well designed, and they would have to be long term. It would be expensive, but you know, these are things that should be discussed. Yeah, absolutely, yeah.
All right, Jeff. Well, it's telling us we're down to 0. I'm having too much fun, but
okay.
we still need to end.
Okay.
Thank you for coming out. I mean, just to close real fast, the future of the NIH is going to look very different than the past. It'll look the same in one sense. Like the NIH has a century of real accomplishment in advancing biological knowledge. That will be the same. But the set of things we ask about, the way that we go about it, the openness, the academic freedom, is completely different. Hopefully you heard that in the spirit of our conversation. Thanks. Thank you, Jeff.
Thanks.
So much for joining us. It's been an inspiring and impactful day. The work is just getting started. So thank you again. For those of you staying for lunch, please join us across the hall and please be in touch. We're in this together. Thank you.